Dr. Joshua Pierce, Michigan Tech University, Open Source Technology Lab. What is it? Where are we?
This is the Michigan Tech Open Source Sustainability Technology Lab. So everything that we're working on here is to try to drive sustainability forward using open source development protocols. We have a large bank of rip-wrap style 3D printers. You can see various versions of them in various states of assembly and disassembly, and we're constantly innovating on them to try to make them better. So we use the 3D printers here primarily to build scientific equipment for our own use. We open source the plans and everybody else can use them. So as an example, this is a PL setup. That's photoluminescence that you use to characterize the band gap of a solar cell material. And of all of the fixtures, these are magnetic bases that we're putting on a steel fake wood tabletop. We're able to make an optical setup much less expensively, 90 to 99% cheaper than to buy one completely commercial. And everything can be 3D printed. So we've done very complicated things from automated equipment that's been 3D printed to very simple things like simple holders. I've got an open source, so this is the laser store, open source laser cutter in kind of various states of
completion. You're doing it all yourselves?
Yeah.
Mm-hmm.
We also do a lot of recycled plastic. So in the back here is one of the versions of the recycle bot. And the idea is you take a milk jug, you clean it, cut it up, throw it through a standard office shredder, and you get...
Standard office shredder?
Yeah, so that's the kind of shredder that you would use for like cutting up CDs, DVDs, and you get out kind of chunks and pieces. You throw it in this hopper. This is a windshield wiper motor attached to a standard rep-rap power supply that runs a chain that pushes a wood auger through a hot zone that melts out your filament. And so we've got, you can drive the filament out and have it go on the floor, and that works okay. It's a little bit better if you actually pull it out under some control. And so we've been using the Filowinder, which is an open source winding tool, and I can show you some examples over there, that gets you relatively good filament. If you make filament from recycled plastic using this, it costs 10 cents per kilogram. 3D printed filament is $35 to $50 commercially, so it's significant.
Per dollar, per kilogram.
So it's massive, significant improvement.
Let's show the winder.
So here's one partially built, and there's one completely built over there.
Partially built.
Now let me show you how far we can take this. So if you turn around and look here, this thing that looks like an old file cabinet is actually an open source laser polymer welding system. And so we borrowed plans from an open source laser cutter.
Laser polymer welding.
Laser polymer welding. And so the idea here is we're taking garbage bags and turning them into heat exchangers. And so we're able to pattern any pattern that we'd like. And the idea is you have a hot layer going through the first layer, cold through the second, and so forth and so on. So we can make the least cost heat exchangers imaginable as long as you can handle the temperatures with a particular polymer that you're using. So we are literally using garbage bags to make heat exchangers. And that particular project was for a solar water pasteurizer for the developing world. The total cost has to be under $25 to make sense. The heat exchangers made out of metal were $250. And so this is our solution, open source, start to finish. When we made the first one that Bjbjvkvcgc got his PhD thesis on, that cost $3,000 to do the prototyping commercially. This entire setup cost less than that. We saved tens of thousands of dollars doing all different types of designs for it. We've got other types of printers. This is a Trinity. It's an open source 3D printer. We have a metal print head on it that we use for doing higher temperature plastics, polycarbonate, HDPE type printings. And let me turn off and I'll show you some other stuff.